Welcome to the lecture series of linear equations in one variable. In our earlier two classes, we have solved many problem sums based on linear equations. In today's class, we will be applying the concept of linear equations practically. So today's class will be an interesting one. So let's solve one by one. The first problem sum says the numerator of a fraction is 6 less than the denominator, and if 3 is added to the numerator, then the fraction will be equal to 2/3. Then what is the original fraction? So what we will do is we will assume that the denominator of the fraction is x, where x is the variable, unknown variable, for which we will form an equation, and finally we will solve that equation to find the value of x. Now, as per the problem statement, it says that the numerator of the fraction is 6 less than the denominator. So if the denominator is x, then the numerator will be what? Numerator will be 6 less than the denominator, so x minus 6. And so what will be the fraction then? Numerator, which is x minus 6, divided by the denominator, which is x. Now if 3 is added to the numerator, then the fraction is equal to 2/3, 2 by 3. So if we add 3 to the numerator, that means the numerator will be then what? Numerator will be, initially the numerator was x minus 6. So if we add 3 to that, then it will be x minus 6 plus 3. So the modified numerator will be x minus 3. But the denominator remains same. So the fraction will be what? The new fraction will be numerator by denominator, that will be x minus 3 divided by x, and that is equal to 2 by 3 as per the problem statement. So what we have to do is, now from here we can form an equation. So it will be 3x minus 9, and that will be equal to 2x. So if we simplify further, then it will be 3x minus 2x, and 9 we will take on the other side. So finally the value of x will be 9. And what is x? X we assumed as the denominator of the fraction. So finally, if the denominator of the fraction is 9, then definitely the numerator, which is 6 less than denominator, that means it will be 9 minus 6, 3. So the fraction will be what? Fraction will be numerator divided by the denominator, that means it will be 1 by 3. So this is how we solve, or we apply the concept of linear equations in our practical life to solve practical problems. Now the next problem sum, what it says, a sum of rupees 800 is in the form of denominations of rupees 10 and rupees 20. If the total number of notes be 50, then find the number of notes of each type. So here also we have to again assume the total number of denominations of either rupees 10 or rupees 20, and accordingly we have to form the linear equation of that variable, and then finally we will solve for that variable. So first what we will do is we will assume that the number of denominations of rupees 10 is x. Fine. Now as per the problem statement, total number of notes is 50. That means total number of denominations of rupees 20 will be what? Total number of notes is 50, and total number of notes of rupees 10, or denominations of rupees 10, we have assumed as x. So it will be 50 minus x. Fine. So if we have x number of rupees 10, that denomination, so the total valuation will be what? Total valuation will be x, the number, and for each note the valuation is 10. Similarly, total number of notes for rupees 20, for that denomination is 50 minus x, and for each note the valuation is 20. So this is the total valuation of all those rupees 10 and rupees 20 denominations, and here the sum of all those denominations is what? As per the problem statement, it is 800. So definitely this sum will be equal to 800. So this is our linear equation of this variable x. Now if we simplify this further, we can easily find the value of x. So it will be 10x, then 50 multiplied by 20, it will be 1000, then it will be minus 20x, and on the other side we have 800. So if we simplify further, it is 10x minus 20x, so minus 10x, and on the other side it is 800 minus 1000, so it will be minus 200. So minus 10x is equal to minus 200, that means 10x will be equal to 200. So from here we can easily say that what will be the value of x? Value of x will be 20. So total number of denomination of rupees 10 will be 20 number of rupees 10 notes, and total number of denominations of 20 rupees 20, that will be 50 minus 20, that means 30. Now if we want to verify the result, whether we have obtained the correct value or not, we can verify. 20 number of rupees 10 note, so total valuation will be 20 multiplied by 10, and then 30 number of rupees 20 note, so it will be 30 multiplied by 20, so it will be what? It will be 200, and from here it will be 600. So total valuation is 800, and that's what it was given in the problem statement. So it is proved. Now the next problem sum says that Elena has rupees 9 in 50 paise and 25 paise coins, somewhat similar to the previous one. Now she has twice as many 25 paise coins as she has 50 paise coins. So we have to find that how many coins of each kind does she have. So what we will do, here it is given that she has twice as many 25 paise coins as she has 50 paise coins. So we will assume that the total number of 50 paise coins that she has is x. So if that is x, then as per the problem statement, total number of 25 paise coins will be what? Twice. It is given. So it will be 2x. And Elena has total rupees 9. So how we will solve this? X is the total number of 50 paise coins, and 50 paise means how many rupees? It is half. We know that 50 paise means half rupees, and she has 2x number of 25 coins. So 25 coins means how much rupees? It is 1/4. So 1/4, and this total valuation will be equal to 9 as per the problem statement. So this is the linear equation, and if we solve this, we can find the value of x. So x by 2 plus x by 2, that means x, and that is equal to 9. So it's very easy. That means x, what we assume, total number of 50 paise coins was x. That means total number of 50 paise coins is 9, and total number of 25 paise coins will be 18. So 9 is total number of 50 paise coins, and for each coin the valuation is half rupees. And we have 18 number of 25 paise coins, and for each coin the valuation is 1/4 of the rupees. So it will be how much? It will be 4.5, and it will be 9 by 2, that means again 4.5, and in total it is 9 rupees, and that's what it was given in the problem statement. That means it is also verified or proved. Now the next problem sum says that Bobby is twice as old as Tom. Okay, fine. If 6 years is subtracted from Tom's age and 4 years added to Bob's age, then Bob will be 4 times Tom's age. Now we have to find how much old they are at present, and then how much old they were 2 years ago. So we will start this problem with their present age, and then easily we can find their past age or future age. So what we will do is, here it is given that the Bob is twice as old as Tom. So we will start with Tom's age. So we will first assume that the Tom's present age is x. So what will be then Bob's present age? It is twice as old as Tom, so it will be 2x. Now if 6 years is subtracted from Tom's age, what is Tom's age? Tom's present age is x. So if 6 years is subtracted from Tom's age and 4 years is added to Bob's age, Bob's present age is what? 2x. So if 4 years is added to Bob's age when 6 years was subtracted from Tom's age, then what is the relationship? Bob will be 4 times Tom's age. So this is Bob's age and this is Tom's age. So Bob will be 4 times of Tom's age. Now this is the linear equation which we have to solve, and we will finally get the value of x. So if we simplify further, it will be 4x minus 24, and from the right side it will be 2x plus 4. So it will be 4x, and now 2x if we take on the left side, it will be minus 2x, then here 4 plus 24. So from here it will be 2x, and that will be equal to 28, or x will be equal to 14. So x is 14 means what? X is 14 means Tom's present age. So Tom's present age is 14 years. So Bob's present age will be then 28 years if Tom's is 14, because twice, and what we have to find is how old were they 2 years ago. 2 years ago means Tom 2 years ago was 14 minus 2, it was 12 years, and Bob 2 years ago was 28 minus 2, 26 years old. So this is how we can solve this type of problem. Now the next one is 5 years ago a man was 7 times as old as his son. 5 years ago. And then 5 years hence the father will be 3 times as old as his son. So find their present age. So we will start solving this problem with their present age. So let's assume that the son's present age is x. Fine. Now the first relationship that is given is 5 years ago the man was 7 times, means the father was 7 times as old as his son. So first we have to find that how much the son was old 5 years ago. So if the son's present age is x, then 5 years ago the son's age was x minus 5. And father was 7 times as old as his son was 5 years ago. So father's age 5 years ago was 7 multiplied by x minus 5. So this x minus 5 and 7 multiplied by x minus 5 are their ages 5 years ago. Now there is another relationship given, and that is 5 years hence the father will be 3 times as old as his son. So after 5 years the son's age will be what? The current age is x. So after 5 years the son's age will be x plus 5, right? And what is the current age of the father? If 5 years back the age of the father was 7 multiplied by x minus 5, then the present age of the father is 7 multiplied x minus 5 then plus 5. And after 5 years, even from now, the age of the father will be this, right? So if we simplify further, then it will be 7x minus 35 then plus 10. So it will be 7x minus 25. These are the ages of son and fathers after 5 years. And what is the relationship? That the father will be 3 times as old as his son. So this is the current, this is the age of the father after 5 years. So that age is 7x minus 25. And that is 3 times of his son's age. So 3 multiplied by x plus 5, right? Now what we have to do is we have to simplify further to find the value of x. So it will be 4x, and that is equal to 40. That means x will be equal to 10. And what is x? X is son's present age. And what we have to find is find their present ages. So son's present age is x, and that we have obtained as 10 years. And for father's present age will be what? Father's present age is 7x minus 5 plus 5, because 7x multiplied by x minus 5 was the father's age 5 years ago. So it will be 7, then 10 minus 5, then plus 5. So it will be 35 plus 5, so 40 years. Next, see what is waiting for us. The next problem sum is, at a party, colas, squash and fruit juice were offered to guests. So there were 3 types of drinks: colas, squash and fruit juice. A fourth of the guests drank colas. Fine. A third drank squash and 2/5 drank fruit juice. So first what we will do is, so we will assume that the total number of guests in that party is X. Colas, how many of them drank colas? 1/4. A fourth of the guests, they drank colas. That means 1/4 multiplied by X. So these many people drank colas. Then for squash it is a third. So 1/3 of the guests, they drank squash. So it will be 1/3 multiplied by X. And 2/5 drank fruit juice. So 2/5 multiplied by X. 2/5 of the total guests, they drank fruit juice, and there were three guests who did not drink anything. And summation of all these number will be the total number of guests. That means X by 4, which is the total number of people or guests who drank colas. Then there will be X by 3. Then there will be 2X by 5. And there were 3 who did not drink anything. So this total number of guests will be equal to X, and that's what we have assumed. So now simplify this linear equation, we can easily find the value of X. So it will be X minus, and that will be equal to 3. So if we simplify further, then it will be X minus, here the LCM will be 12 and then 5, it will be 60. 4 3s are 12. 12 5s are 60. So here it will be 15x. Then here it will be 60 by 3, it will be 20. So 20x. Plus it will be 60 by 5, it will be 12. 12 2s are 24x. And that is equal to 3. So if we simplify further, then it will be x minus 20 plus 24, 44, and then 15. So it will be 49. 59x. Divided by 60, and that is equal to 3. So it will be 60x minus 59x divided by 60, and that is equal to 3. So x by 60 is equal to 3. That means x will be equal to 60 multiplied by 3. That means 180. So total number of guests in that party was 180. Next and the last problem of this class is, Ravi has 3 boxes whose total weight is 60.5. So the total weight of 3 boxes is 60.5. That means 120 plus 1, 121 divided by 2, that much kg. Box B weighs 3.5 kg more than box A. 3.5 kg means what? 3.5 kg means 7 by 2 kg. And box C weighs 5 1/3 kg more than box B. So 5 1/3 means how much it is? 15 plus 1, 16 divided by 3 kg. And finally we have to find the weight of box A. So we will start solving this problem from that point only. So we will assume that the weight of box A is X. Fine. And what is the weight of box B? Box B weighs 3.5 kg more than box A. So weight of the box B will be X plus 7 by 2. This much kg. And this is also in kg. And weight of the box C is how much? Weight of the box C is 5 1/3 kg more than box B. Weight of the box B is X plus 7 by 2. And then it is the weight of the box C is 5 1/3 means 16 by 3. So it is 16 plus 16 by 3, and that will be the weight of the box C. And the total weight of this box, of all these 3 boxes, is 60.5. That is 121 by 2. So the linear equation will be X means box A, then X plus 7 by 2, that means weight of box B, and then X plus 7 by 2 plus 16 by 3, which is the weight of box C, and the total weight of all these boxes is 121 divided by 2. So we have to simplify further. So it will be 2 and 3. If we take the LCM, then it will be 6. So it will be 6x, then 6x, 32, and that will be equal to 121 by 2. So 6x plus 6x plus 6x, it will be 18x, and then here it is 21 plus 21, 42, and plus 32, it will be 74 divided by 6, that will be equal to 121 by 2. 2 and 6, if we simplify, here the factor that will remain is 3. So here 18x will be how much? 18x will be 121 multiplied by 3. So that is 363 and then minus 74. So from 363, if we subtract 74, then it will be 289. So the final value of x will be 289 divided by 18. This much kg. That means weight of the box A is 289 divided by 18 kg. So in this class, we have solved 7 problem sums related to linear equations in one variable, and they have really practical applications. By using that concept, we can solve many practical problems. So in the next class also, we will be solving a few more interesting and complex problem sums related to linear equations, and they also have practical applications. With this, I end today's class. Thank you.